Today's video lesson is about the intermediate value theorem. You could pretty much read the paper um, and figure out what the intermediate value theorem is. And if you're comfortable with that, you don't need to watch the video. If you'd like to hear me talk it through, please continue listening. So the intermediate value theorem is actually relatively silly that we actually have to state it because it kind of makes perfect sense. So basically what it's saying is if I've got 2 points and I have a curve between them. So we're talking about the 2 points A and B. Those are my 2 points. I've got a line. Here's my line. Then if I have a point that's below the line and I have a point above the line, then there has to be at least one place where the curve and the line cross. That's all the intermediate value theorem is. And of course, that makes perfect sense. So we're talking also specifically about something being continuous. In order for the intermediate value theorem to be true, the function that we're talking about has to be continuous. No gaps, no jumps, and we're going to get a better definition of continuity. Well, we got a better definition of continuity in the last video lesson. So just for talking about continuity, I can draw it without lifting my finger or my pen from the paper. So let's look at the more formal mathematical version. So if I have a function y equals f of x, and it's continuous over the interval from a to b are the x values. Okay, so my a and my b are my x values. And w is a number between f of a and f of b. So w is actually a y value. And f of a and f of b, those are also y values. F of a is just the y value at x is a. F of b is the y value at x is b. So there's some w that lies in between the two y values. So we know that there's at least one value of x that has to be in between our a and b. Here's that value of x has to be in between the a and the b, so that my w has to lie in between the two y values, f of a and f of b. So that's the mathematical way to state the intermediate value theorem. And that's in another way. So we can also say at least one value c, which means if you look at this graph, there doesn't just have to be one x value where I plug it into the function and the function value is equal to this wy value. You could have multiple ones. I could have many ones. I could have infinitely many ones, especially if you're talking about a sine function or a cosine function that's going to continuously repeat. So here's the key. How is this useful? Well, if I can show there's a point above a line, a point below a line, and the curve is continuous, then there has to be a value in between those x values that has to be on the line. So let's look at an example of this. So is there a solution to x to the fifth minus 2x cubed minus 2 equals 0 between x equals 0 and x equals 2? I have no idea. So what I'm going to do is I'm just going to take my x equals 0 and I'm going to plug it in right here. So I get 0 to the fifth minus 2 times 0 cubed minus 2, and that thing equals negative 2. So when x is 0, if I draw myself a little graph, when x is 0, my y value is at negative 2. Okay? So now we're going to look at x is 2. And again, I'm going to take x is 2. I'm going to plug it into my function. I have 2 to the fifth minus 2 times 2 cubed minus 2. That number is 14. So when x is 2, my y value is 14. Now, my polynomial function is continuous, so I meet that requirement of the mean value theorem. I have no idea. I just drew something in to connect the dots, basically. But here's the key down here. When x is 0, the y value is negative 2, which is below 0 as a y value. At x is positive 2, the curve is above 0. It's at 14. So what that means is there has to be at least one place in between x is 0 and x is 2, where the y value of the function x to the fifth minus 2x cubed minus 2 has to be equal to 0 by the intermediate value theorem. So I must state that the function is continuous in order to use the intermediate value theorem. I've got to state what those two y values are using the given x values. Then I must state that the y value I'm looking for, in this case was 0, is in between the -2 and the 14 that I got from my function. So that's the intermediate value theorem.